study the elevation in boiling point act as a colligative property. Before going to that topic, we will study what is a colligative property. These are the properties which depend upon the number of solute particles in the solution and do not depend upon the nature or the type of the particles, nature or type of the solute particles. These properties are sometimes we also call them democratic properties, because it is the democracy in which the number of persons are counted, number of persons matters, so it is also called the democratic properties. Now what is, before studying the elevation and boiling point, we will study what is the boiling point. Boiling point is a temperature at which vapor pressure of a liquid becomes equal to the atmospheric pressure. So that temperature at which vapor pressure of the liquid becomes equal to the atmospheric pressure is known as the boiling point. Now when a non-volatile solute is added to a solvent in this and the solution so formed, that means the solution of non-volatile containing non-volatile solute, we know the vapor pressure of the solution gets lowered or is lowered by addition of non-volatile solute. So that means the solution is to be heated to a higher temperature. Solution is to be heated to a high temperature so that its boiling point becomes equal to the atmospheric pressure. When we add non-volatile solute, vapor pressure gets lowered. That means vapor pressure of the solution is less than that of the solvent. So when we heat, the solution has to be heated to the higher temperature so that its vapor pressure becomes equal to the atmospheric pressure. That is, boiling point of solution increases as compared to that of the pure solvent. Now let us study the elevation in boiling point. We have seen that in case of when a non-volatile solute is added to the solution, the boiling point gets increases. That means there gets a difference in boiling point of solution and solute. That is called elevation. It gets elevated. Elevation in boiling point, because boiling point of solution is higher than that of the pure solute. So then boiling point of the solution higher than that of the pure solvent. Boiling point of the solution containing non-volatile solute is higher than that of the pure solvent. There occurs difference between in the boiling point of the solution and the solvent. Boiling point of solution is higher than that of the solvent. So this difference in the boiling point is called elevation in boiling point. Now this we will study graphically. Now let us take, look, this is the graph. Now this is the temperature curve. We'll study the graph. This is the vapor pressure, and here this is the atmospheric pressure, 1 atmosphere. This is the, I will write, this is the AB curve of AB curve. This is the vapor pressure curve of the pure solvent, and this is the vapor pressure curve of the solution. I have kept vapor pressure curve solution below that of the solvent because vapor pressure of the solution is less than that of the solvent. Now when we increase the temperature, this is the temperature here, so vapor pressure of the solvent increases and it meets the atmospheric pressure, that is X. Now X corresponds the temperature, this is pure, it corresponds, it is T omicron Bre. And similarly, vapor pressure, when we increase the temperature, vapor pressure curve with this vapor pressure increases and it meets the atmospheric pressure, that it is Y. at point y. So let this y corresponds to this temperature. This is TB. Here boiling point of solution becomes is higher than that of the pure solvent. Therefore this difference in boiling point, I'll write it del TB. Del TB is equal to, it is TB minus T omicron B. TB is the boiling point of solution and T omicron is the boiling point of the pure solvent. Since boiling point of the solution is higher than that of the solvent, so difference becomes this difference becomes elevation in the boiling point. Now this del TB, it is proportional to molality of it has been determined experimentally that elevation in boiling point is proportional to the molar concentration, or I will write del TB is equal to, I will change proportional constant equality, then I will write here Kb into m. M is the molality, where m is the molar concentration. That is number of moles dissolved per kg of the solvent. So if molality of the solution is 1, that is 1 gram mole is dissolved in 1 kg or 1000 grams of the solvent, then del TB becomes equal to Kb. Kb is the constant, it is called molar boiling point elevation constant, या elliptic constant. Now we will define molar elevation boiling point constant. We have taken molarity as 1, therefore molar elevation constant or elliptic constant is the increase in boiling point of, it is the increase in boiling point of 1 molar solution. When we dissolve 1 mole of solute, when we dissolve 1 mole of solute in 1000 grams of the solvent, that is called 1 mole solution. 1 gram of, if we dissolve 1 gram mole, or we say 1 mole of the solute in 1000 grams of the solvent, that is called 1 mole solution. So in that case, how much elevation takes place, that will be the molar elevation constant or elliptic constant. Now from this elevation constant we will determine the molecular mass of the solute. We have seen that del TB is equal to Kbm. I will define molality. Molality is number of moles of solute dissolved per kg of the solvent, per kg, or we say 1000 grams of the solvent. Therefore it is molality is equal to m is equal to number of moles of solute divided by weight of solvent in grams into 1000. Since we take here number of moles into consideration, that del V depends on number of moles of solute, it is a colligative property. Then elevation and boiling point is a colligative property, because here we say that number of moles of solute. So del TB depends upon number of moles of solute, so it is a elevation and boiling point, we say it is the colligative property, since it depends upon the number of moles of solute in the solution. Now molarity we have defined here, it is number of moles of solute divided by weight of solvent. Let WB grams of solute are dissolved in WA grams of solvent. That is, I have taken B as solute and A as solvent. Let WB is the mass of solute, WA is the grams or the mass of solvent, WB grams are the mass of solute, and WA grams are mass of solvent. let mb is the molar mass of solute, या we can molecular mass, molecular mass of solute, and w ma is the molecular mass of the solvent. From that, from this equation we will write number of moles. Number of moles is equal to mass of solute divided by molecular mass, or divided by molecular mass. That is, it is del Tb is equal to number of mole is equal to Wb, molarity is equal to Wb divided by Mb, mass of solute divided by mole mass of solute, into 1000 divided by weight of solvent into We. We will substitute the value of M in this equation first. So del Tb is equal to, it is Kb वहीं पर रहेगा, M molarity को हम वैल्यू लेंगे, it is Wb divided by Mb into 1000 divided by We. So from this we can divide the mole mass of solute, molecular mass, we can Mb is equal to, it is Kb into Wb into 1000 divided by del Tb into We. By this we have calculated the molar mass of this, molar mass of the solute. Now molecular mass हमने निकाला, अब यहाँ पर Kb टर्म आ गई. This Kb is equal to mR. M is the molecular mass, R is the gas constant, Tb square divided by del H vaporization into 1000. ऐसे हम Kb का वैल्यू निकाल सकते हैं. This is the way how we, what is the elevation and boiling point, how we define the molecular mass on